Here we're going to look at two and three-way proportion. Two-way proportion is basically when two things are varying and they might be in direct proportion or inverse proportion. Actually, we've looked at that already, but here we're not going to be creating equations and use the proportional symbol and k and so on. We're just going to use our intuitive sense of those two ideas of proportion. Three-way proportion is then when you've got three things, and maybe they have some direct relationships, maybe they have some indirect. Maybe it's one doubles, another one halves, but the other one, like there can be both direct and inverse proportions going on in the same question, basically. Okay, let's take a look first at two-way proportion. So Fred takes 2 hours to dig a hole. How long will it take him to dig three holes? So we know when we're solving this sort of problem, we're using intuitive feel really. We know it's going to take longer to dig three holes. It seems to be taking 2 hours per hole. So we're simply going to do 2 times 3, which is 6 hours. This is direct proportion. As I double the number of holes, I would expect to double the number of hours. As I triple the number of holes I'm digging, I would expect to triple the number of hours, which is what we've done here. What assumption have we made? We've assumed he can work at the same rate. Assumed constant rate of work. Okay, because we couldn't really feasibly expect him to work 24 hours straight and dig 12 holes, for example. That's just not realistic. But this is a maths problem, and it's like a mathematical model. So that was a two-way proportion problem, and there's essentially a direct proportion going on here, but we never wrote down the proportional symbol. Second question, 4 pipes take 20 minutes to water a field. How much time will it take to water the same field with 5 pipes? So here we'd expect intuitively, as the more pipes we use, the less time it's going to take. And so this is an example of two-way inverse proportion. Again, I'm not going to write down any equation, I'm just going to think about it. How long will one pipe take to water the field? Well, it's going to take longer. It's going to take 4 times as long as I would expect. So it's going to be 80 minutes. And therefore 5 pipes, what am I then going to do? I'm going to divide by 5, and that's going to be 16 minutes. And that seems about right. It's less than the 20 minutes, but not a lot less. I've used the ideas of indirect proportion. Let's look now at three-way proportions. So here we go. It takes 5 carpenters 5 hours to make 5 chairs. We've actually got three sort of variables here that are related. And if we just think about it, if I were to double the number of carpenters, then in the same amount of time, I could double the number of chairs. So carpenters and chairs are in direct proportion when time is fixed. If I keep the number of chairs fixed at 5, if I double the number of carpenters, then I could halve the amount of time. So for fixed number of chairs, carpenters and hours are in inverse proportion. So you get a feel really that these things have a relationship, and it's important to just be really careful, but be intuitive as we're solving this. So my recommendation for this sort of problem is to make a little column for carpenters, time, and number of chairs. And then I start with 5, 5, 5. And where I want to end up to is how long it would take 40 carpenters to make 100 chairs. So this is sort of our end goal. So I think the first thing I do is I think I'll keep the number of chairs fixed and change the number of carpenters to 40. So what am I doing there? I'm timesing by 8. And if I choose to keep the number of chairs fixed and say I still want to make 5 chairs, then what's going to happen to the time? Well, if I've got 8 times the number of carpenters, then I'm going to divide the time by 8. So it's going to become 5 divided by 8. So I've divided this one by 8 because of the inverse proportion essentially. So I've got the 40, and now I'm going to keep this one fixed. So on the next one, I want 100 chairs. So I need to times that by 20. And actually, if I need more chairs, if I double the number of chairs, then for a fixed number of carpenters, I'm going to double the amount of time it takes. So these two are in direct proportion. So I'm now also going to do 5 over 8 times 20. And then I can work that out. And I get 12.5. And that's my answer because I've got my 40 carpenters, I've got my number of chairs, and now I've got my time. So 12.5 hours is what I would expect. As before, I've assumed that, if you have more, like double the number of carpenters, like I've assumed these proportional relationships. But that's, we can do that in this sort of question. We just need to be aware that we've made these assumptions and look. You just need to, set the working out as a careful table and think, as I keep one the same, if I double one or times it by something, what happens to the other one, and just think intuitively. Okay, let's do one more example on this. If 6 workers can build 4 cars in 2 days, then how many days would it take 8 workers to build 6 cars? So again, let's get a table down straight away. Actually, so I've got my workers, and I've got 6. I know they can build 4 cars, and how many days? All right, D for days, 2. So I think I'm just going to get straight into it. How many days would it take 8 workers to build 6 cars? So I think what I'll do first of all is work out. What shall I do? I'll keep cars as 4, but now I've got 1 worker. How many days would it take for them to make 4 cars? Well, what I've done here is I've divided by 6. I've divided the number of workers by 6. Now, if I've got less workers, it's going to take longer. So there's an inverse proportional relationship here. I'm going to times this one by 6, and I've changed the number of days to 12. Right, I've made it 1 because now I can change it to 8 workers. So it's always a good idea to get down to 1 if as a little tip. So now I'm timesing the number of workers by 8. I'm going to keep the number of cars fixed at 4. What's going to happen to the number of days? That I'm going to divide by 8 because of this inversely proportional relationship, and I'll just write 12 divided by 8 here. And I've managed to get my 8s, so I'm all set. I'm now going to keep this one fixed. Okay, so it's going to be 8 here. Now I'm interested in making 6 cars. So I think I'll first of all work out what 1 car would be. So what have I done? I've divided by 4. Okay, 12 over 8, by the way, is 1.5. I probably should have just written 1.5. So if I'm dividing the number of cars by 4, it's going to take less time. I'm going to divide that by 4. I'm going to do 1.5 divided by 4. Yeah, so I divide by 4 again, and this is going to give me 0.375 days. Okay, I'm nearly there. 8 workers, keep this one the same. I want to build 6 cars. So now I've times by 6 the number of cars. So the amount of time I'm also going to times by 6. I'm going to take my 0.375. I'm going to times it by 6, and we get 2.25 days. That's my answer. I hope that makes sense. I don't necessarily have to go down to 1, but it's a bit. I could have maybe times by 8 over 6 going from here to here. I just thought it was a bit clearer if I went down to 1 worker and went down to 1 car, but this by no means is the only way of doing it. Just look at what I've done. I've kept one thing fixed, I've changed the other two, and I've thought carefully how they relate. And if you do that, then you can solve these three-way problems, just being careful.